Okay, welcome to Unit 4, the periodic table. We will be discussing a little bit about the history and the development of the table and group and general periodic trends. Also within this, we'll talk a little bit more about the organization of the table and where different parts of the table are. This is a super important unit because it will help you understand patterns, and it will also be a great introduction to chemical bonding. And we'll talk about different types of bonds in the next unit, and to locate the element on the table and talk about how it will react with other elements is a key focus of that unit. So you really have to be familiar with the table and be able to use it as a predictive tool. Shakespeare said, "The whole world is a play, and men and women merely actors in the play." In our periodic chemistry play, the periodic table holds all the characters and the characteristics. Say that 4 times quick. So let's get to it. Okay, so it really kind of started with this fellow, and this guy is known as Dmitri Mendeleev. And Dmitri was known as the father of the periodic table. He was a Russian scientist that was working on characteristics of elements and grouping elements in order by properties and mass. And he had a set of cards that he used to make notes on, and he would move the cards around and try to make sense of an order of the periodic table. And what he and others noticed was that when he put the elements in order by mass, that the first 8 had kind of dissimilar characteristics, but the 9th element tended to have elemental characteristics of the first one. And so he started putting those in groups or vertical columns. And what he also observed was that it didn't always fall true. And so he'd be going along and placing cards in order, and he would notice that maybe a card didn't exactly fit in that group. And he thought, well, it fits really better in the next group. And so what he proposed was, or what he thought was, that there was an element there that was not known at the time. And so he left blanks for these unknown elements. And that, to a large extent, separated him from all the other scientists working at the time. And I think that's why he was given a lot of the credit for the early periodic table and being the father of the table. So here it says he left blanks in his table where he estimated unknown elements to be. And of course later on they found those elements. And so behold the turtle. He only makes progress when he sticks his neck out. And so this was a kind of a risky type of deal for Mendeleev. He was a little bit different than the rest, and so this really distinguished him from his other scientific colleagues working at the time. Okay, so we have a guy by the name of Henry Moseley that also was working at the time, and we'll talk about him in a second, but let's continue on with Mendeleev. Mendeleev proposed the first periodic law, which stated that the periodic properties of the elements are a function of their atomic masses. And this was really a great place to start. And he was, of course, given a lot of credit here. But as they went along, they noticed that there were some problems with the order of the table based on mass. And so that there were some exceptions, even with the leaving of blanks for undiscovered elements. And so what Moseley did was he came behind and he discovered the number of protons in each one of the elements. And when he rearranged the elements by atomic number or the number of protons, it took care of the discrepancies in Mendeleev's table. And so He is known as the father of the modern periodic law, which states that the periodic properties of the elements are a function of their atomic number. All right, I thought that this was a very interesting graphic that Wikipedia has, and they have a history of the discovery of elements here. And if you will notice here that in antiquity, back in early times, they knew of about 12 elements. And then this increased through the Middle Ages, where they added 22 new elements. And then the biggest discovery of elements was in what they call the Scientific and Industrial Revolution. And this was about 1800 to 1849. So if you add all those up, 12, 22, and 25, you come up with 59 elements that were discovered by 1849. And then over time, we found more and more elements, and now we're up to 118. One of the things that's interesting is the new elements that are discovered are really as a result of nuclear fission reactions. They take large elements and they split them apart, and they've come up with these very short-lived elements. They may only last fractions of a second. And the discovery of these is in hope that we will find some usage for these short-lived phenomenons. Okay, so now we will talk about group trends, different characteristics of the elements that are in the vertical columns on the periodic table. Groups travel vertically up and down on the periodic table, like so. So this is group 1, and this is group 2, group 13, group 14, etc. And periods travel horizontally or across the table. So you have period 1, period 2, period 3. Sometimes they call the periods, they'll call them series, and sometimes the groups, they will call them families as well. And we have two broad categories of elements on the table. We have our metals and our nonmetals. And they are separated by a stair-step line that extends down the table, starting here in between periods 2 and 3 and in group 13. It's a stair-step line like so. So everything to the left of that stair-step line is considered to be a metal. Everything to the right of the stair-step line is considered to be a nonmetal. Some of the elements that touch the division are called metal or metalloids. We'll talk a little bit more about those as we go along as well. But first, some just general characteristics about metals. Metals tend to be shiny or they reflect light. They're malleable, which means you can bend or shape them. And they are good conductors of heat and electricity. In the next unit, we will talk about chemical bonding, and we'll talk about metallic bonding. And in metallic bonding, the electrons are free to travel across the surface of that metal, and that makes them really good conductors of heat and electricity. They tend to lose electrons and react with nonmetals to form ionic compounds. Group 1 on the periodic table is called the alkali metals. This is group 1, from lithium on down to francium. Hydrogen is kind of an interesting element in the fact that it can lose an electron or gain electrons. And so sometimes you'll see even hydrogen put over here on the nonmetal side. But lithium, sodium, potassium, rubidium, and so forth form the alkali metals. And alkali means base forming. And so when these metals react with water, they form basic solutions. They form hydroxide ions in solution. And that's where that word alkaline or alkali comes from. They react as the reactivity increases as you go down a family. So the ones on the bottom are super reactive. The ones on top are reactive as well, and they will react with water to form the hydroxide ion, which makes them basic, plus hydrogen gas, which can be explosive. And when these are found in elemental form, if you have them in an elemental form, you usually have to store them in some sort of oil because they react so violently with water. They form positive one cations by losing an electron. They react violently with water and rarely found in elemental form. We've already said that. In the group 2 elements here, group 2, are called the alkaline earth metals. And they have 2 valence electrons. They form positive 2 cations. They are not quite as reactive as the alkali metals or the group 1 metals here. They're not quite as reactive, but they are reactive. And as you go down the group, they get more and more reactive as well. So then we will talk a little bit about the group 3 through 12 elements. These are called the transitional metals. And of course, you're transitioning from a metal to a non-metal as you go across the group. The chemistry of these elements is very, very cool. They're used in lots and lots of materials, and they have really unique properties. The elements under each one of the groups tend to have similar properties, but the chemistry is really complex here. And of course, you'll recognize some of these like iron and nickel and copper and silver and so forth and zinc. They are used in lots and lots of different applications. Continuing on, group 17 here are called the halogens. And they have 7 valence electrons, and they want to gain one to be like the noble gases or become more stable and less reactive. These elements are extremely reactive, and in their elemental form, they are diatomic. All of these are diatomic, except for acetane, which is a radioactive element. In the gaseous state, they can be very toxic. You don't ever want to be exposed to fluorine or chlorine gas. Those can be very deadly gases indeed. And so even though we use fluorinated water and chlorinated water to drink, in the gaseous state they can be really toxic. Groups 1 and 2 in 13 through 18, we call these the main group or representative group elements, the tall groups here. They used to be numbered a little bit differently. So these would be called the 1A and 2A elements. 3A would be 13, 4A all the way through 8A with our noble gases. And then the middle elements were called the B block elements. We tend to just number the groups 1 through 18 now. Group 18 elements are called the noble gases. They were once mistakenly called inert gases because they didn't think that they were reactive at all. But what's really interesting as you go down the group, you can find some compounds with the elements in the bottom of the group. The electrons are so far away from the nucleus that they can be shared in compounds. And so we have found some reactive elements within this group. The lack of reactivity is because of the outer shell. And so when you have a full outer shell, as in the noble gases, this tends to make the elements not want to gain or release electrons. It's a very stable electron configuration. And the only ones that are reactive, like I said before, are the ones down further on the lower end of the table. An example of this is xenon hexafluoride. And so this ends our first recording in Unit 4. And in the next recording, we'll talk more about periodic trends and expand on our knowledge of the periodic table. So we'll talk about metallic character, atomic radius, ionization energy, and electronegativity. Look forward to seeing you in the next recording.